Welcome back, class. So in the last video, we had just learned what it is the fundamental theorem of calculus says. Namely, the fundamental theorem of calculus says that if you want to calculate the definite integral from a to b of little f of x dx, then you need to find a big F of x. This is an antiderivative of little f. Okay, and remember, antiderivative of little f is another way of saying that big F of x is the indefinite integral of little f. Okay, so this ultimately is relating the two kinds of integral, the indefinite integral and the definite integral. And so if we have this, and we have this technical requirement that little f of x is continuous on AB, then we get this formula that tells us how to calculate the definite integral in terms of the indefinite integral. So I want to do some more examples of that today. So I want to start with this integral that we talked about in a video last week. So, reminder, what this integral represents is exactly the area under one sine wave, or 1/2 of one sine wave, one bump of sine. There we go. So, whatever this is, that's what this number is going to tell us, is that area, which we don't have a formula for yet. So this here is my little f in the formula. And so my big F here is supposed to be the antiderivative of sine, which we have said before is minus cosine of x. And so that tells me that the value of this integral is minus cosine of pi minus cosine of 0. Notice there's lots of minus signs here. This minus sign is that minus sign. These two minus signs are this minus sign. But we can go ahead and calculate that, because this works out to be minus 1 minus 1. Which is a very complicated way to write 2. So the integral from 0 to pi of sine of x is 2, meaning this area is 2. Okay. Now, you might recall last week we did a video where we sort of figured out what we could say about this area, and what we could at least say about this area was definitely that it was between pi over 2 and pi. And, well, 2, in fact, is between pi over 2 and pi. So great. What if I take the integral of 10 minus 4x plus x squared dx, and I go ahead and integrate this from 0 to 3. So here's my little f again. It's the function I'm integrating. That's the function I'm finding the area under. And so I need to calculate my big F of x, that is the antiderivative of 10 minus 4x plus x squared. So this is just 3 power rule problems in a row. So that's 10x minus 2x squared plus x cubed over 3. Okay. Please note that you can check that this really is the antiderivative of the thing I wrote down, because if I take the derivative of this big F, I in fact get that. Okay. Note I'm not putting a plus c here because I'm just looking for an antiderivative. That's all the fundamental theorem of calculus requires. It doesn't care which antiderivative, and this is just the one I happen to write down. Okay. But once you have that, then all we have to do to evaluate this integral is take big F of 3 minus big F of 0, which as it happens will be, remember we're plugging it in here, that will be 10 times 3 minus 2 times 3 squared plus 3 cubed over 3, and then minus, and all of these terms are 0. So that all is going to be 0. And that's just because when I plug 0 into F, all of these terms have an x in them, and so they all vanish. So then I can just work this out. This will be 30 minus 18 plus 9, and so this will work out to be 21. And that is the value of this definite integral. Okay, so we have this procedure in place to go ahead and let us calculate all of these definite integrals as long as we can make it through the first step, and the first step is finding this antiderivative. All right, I'll be back with more examples in the next video. But until next time, be well.